Now, we have to examine the atom so we can know how it works and how the atom of elements react in under different conditions and different circumstances, right? Now, when we describe in an atom, we're talking about the smallest part of an element that can exist in nature, but still show chemical properties of that actual element itself, all right? Atoms are so small that we cannot see it with our naked eyes. An atom consists of three types of particles. You have protons, neutrons, and electrons. Protons are usually positively charged, located in the nucleus of an atom, and has a mass of 1. A neutron is usually neutral, no charge at all. It's also located in the nucleus, and it has a mass of 1. So because you have in the nucleus a positive and a neutral charge, because of the proton actually gives the nucleus a kind of positive charge per se, because the neutron doesn't have any charges in it. And your electrons, which actually sit on your shells, and I'm going to show you what it looks like. All right, so structure-wise, this is what it looks like, right? So because of the protons being positively charged, it makes the nucleus positively charged. Each one of these circles are what we call a shell or an orbital, right? They are at fixed distances away from your nucleus, and the electrons sit here. Electrons typically have a net negative charge, all right? Now, on an atom, there are specific numbers that you will see when we start to look at the periodic table. There is a way in which the atom is notated, right? Annotated, I should say. So this is what we call atomic notation. So if X is the symbol of the element, right? You're gonna have a number on top here, and you're gonna have a number underneath here. So I'm teaching you guys the atomic notation. Always remember the bigger number on an atom is the mass number, which is the number of protons and neutrons in any atom. The smaller number is what you call the atomic number. And the atomic number is the number of protons that you have in your atom. So that is what you call the atomic notation. All right, always remember bigger number on the symbol is the mass number, smaller number is the atomic number. The atomic number tells you the number of protons in an atom. The number of electrons in an atom is the same, right, as a neutral, is as the same as the atomic number, right? Once your atom is not electrically charged, the number of electrons are the same as the atomic number, right? So atomic number is the same as number of electrons in a neutral atom. This is an atom that has no charge, because usually atoms that have charges, if it's positively charged, it's going to have more electrons than the atomic number. If it's if it's positively charged, it has less number of electrons than the atomic number. If it's positively charged, negatively charged, sorry, it's going to be more. I'll show you that when we're dealing with bonding, right? Number of neutrons, if you take away the mass number from the atomic number, you get number of neutrons, right? So let me put that here. Number of neutrons is equal to the mass number minus the atomic number. All right. And if you want a classic example of this, right? My mass number here for this question is 40. My atomic number is 20. 40 minus 20 is 20. So I just taught you guys there how to write the mass number, the atomic number, and the number of neutrons, right? And the number of electrons as well is equal to 20 in this case because this atom is not electrically charged. Do you all have any questions here so far? Or you think you're okay with this so far? We're going with this step by step today, all right? We're covering all bases because we need to make sure that you all understand basic stuff here from, all right? Hold on. All right, so this is the points here. When you're finished with this, let me know. Now, I have a list here showing the first 20 elements in the periodic table with their symbols, mass numbers, and atomic numbers. I will share this with you all. I don't know if you guys can take us. Could you all take a picture of this? I don't want to waste time with like copying this down now. Take a picture of this, Summer. You all have to actually know, for exams, the first 20 elements, their mass numbers, atomic numbers, group and period numbers as well. They don't give you the information for the first 20. But you see anything after the first 20, yeah, you're getting it for exams. But you see this here, they expect all you to know this by heart, right? So take a picture of this. Let me know when you're finished taking your picture so I can scroll down into the arrangement of your subatomic particles. Right, so see Vindan, Alim. Everybody else? All right. We're now here, right? Right. So this is what I'm using here as my example, right? Now, Your atom is composed of two parts, right? You have a nucleus that have the protons and the neutrons in it, right? And you also have as well the shells that have the electrons, right? Now, each shell is a different energy level surrounding the nucleus, right? The ones closest to the nucleus have the least amount of energy. The shells furthest away from the nucleus have the most amount of energy. So let's discuss with regards to the maximum number each shell can hold. First one we have here is first shell, which is also known as a K shell, right? You have two of the electrons there. I put P and N in the center to represent my protons. They're supposed to be neutrons, right? Not electrons. It was a boo-boo I made. I will fix it, right? Protons and neutrons. First shell holds a maximum of 2. Second shell holds a maximum of 8. Third shell holds a maximum of 8. Last shell also holds a maximum of 8. Now, some teachers would like if you guys can enclose that nucleus in a circle to represent that as a nucleus by itself. I don't have a problem with it. I would prefer to teach you how to do that one time as well, so that you don't run into discrepancies, because every teacher have different methods in the end of the day. All right. So I would re-enclose this just now to show you all, right? So the first shell has 2, second shell has 8, third has 8, fourth holds a maximum of 8. Some people is teaching model 2, 8, 16, 32. Y'all don't need to know that model for CXC. Let me not confuse and confabulate your brain. Let's keep this as easy as possible. Because for Form 6, you would learn that the third and the fourth shell could actually hold more than 8. But for right now, you need to know the 288 model. Not 2, 8, 16, 32. No, you don't need to know that yet. We're keeping it as simple as possible. So what we're going to do here now is I'm actually going to teach you all how to draw the atoms, right? But before we do that, I actually want to give you guys the example, the how you call this thing? The notes. Then we're gonna go into the example. So we will take down one example at a time, right? So going back here. So you're taking down for me arrangement of the subatomic particles. When you finish with this, let me slide it down. You let me know so I can go down for you. I'll scroll it down, right? I'm gonna make the little amendments here. All right. Why don't I take this down? Are you ready now for the examples? Yes, no, yes, no. Yes.
Yes, miss.
Stop in the share. We're going to do one example at a time here, right? All right. So I just want to clear this whiteboard. All right, so they want you to draw and write the electron configuration for this atom here, which is argon. Argon has 18 electrons, right? So I would start off with putting the P and the N in the center to represent the nucleus, all right? Some people would turn around and say, well, okay, they would write the mass number and the atomic number and the symbol of argon. So if you want to put P and the N in the center to represent argon, if you want to use the symbol, either one is fine. I just have a habit of using P and N to represent the nucleus. Some people just use the symbol, it doesn't matter, right? I am going to enclose my nucleus here now with this particular circle. And then I'm going to go with the shells, right? So first shell first holds a maximum of 2 electrons, 1, 2. That is not 18, right? I still have 16 more to go. My first shell is filled, so I go on to my second shell, which will hold a maximum of 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 2 gives me 10. I have 8 more to go. My second shell is filled. So I need to go on to my third shell now. 1, 2, 3, 4, 5, 6, 7, 8. When we're writing the electron configuration, we're basically writing how much electrons on each shell. The first shell has 2 electrons. Second shell has 8 electrons. Third shell has 8. 8 and 2 is 10 and 8 is 18. Questions there, anybody? Do you all understand how we got to this point?
Yes, miss.
All right, let's take this one down and then we're going on to the next one. Guys, how far you reach?
Finish, miss.
All right, everybody else.
Finished, miss.
Right. We're gonna go with our next one now, right? So all right, so we want to draw the atom and write the electron configuration for chlorine, Cl, and chlorine has the atomic number of 17. Right, start off by identifying your nucleus first, P and N in the center, enclose your nucleus. When that is done there now, you start with your first shell first, right? First shell holds a maximum of 2 electrons. You still have 15 to go. Move on to your second shell. You have to fill one shell in order to go into the next one. Second shell here now. Let's do this thing. Holds a maximum of 8 electrons. We go 1, 2, 3, 4, 5, 6, 7, 8. One thing I forgot to mention is that we draw them in pairs. The electrons in pairs, they typically occur in pairs, so that when bonding taking place, you can see what is a pair, what is a shared pair, what is a lone pair. So make sure when you're drawing your atoms, you draw your atoms in, the electrons in pairs. So 8 and 2 is 10. I still have 7 more to go. So we go in 1, 2, 3, 4, 5, 6, 7. 8 and 2 is 10, and 7 is 17. Let's write our electron config. 2 in the first shell, 8 in the second shell, 7 in the last shell, which is your third shell. And that is your electron configuration and atom drawing for chlorine. Questions, anybody? Any questions? No? All right. So go ahead and take down this example, and then you're going to try some for me next. Let me know when you're finished here. All right, the rest of you guys, where will you reach? All right, I've seen Rebecca finish, Vin finished. Anybody else? All right, just nice. So here's what we're gonna do now, right? So just gonna stop the share. Right, so we're gonna try some of these now on your own. We're gonna correct it, and then we're gonna move on to one little thing again that you need to know with regards to atomic structure, because this is a real simple topic, and you all seem to be busting it up right now. The next thing we're gonna be looking at is isotopes.